Brett, we're going to find out a little bit about shaft currents today. This particular motor is mounted with a shaft current brush attached to it, but the reason for it is that the stator acts as a transformer, and it transforms an induction voltage into the rotor. So the shaft becomes a single turn that has a very low voltage induction, but it has a high current. So what we're going to try to do is show how to take a reading to see if you have a shaft current, and then how we're able to shunt it through the brush to the shaft rather than through the bearing. One of the first things that we're going to do is take the ohm meter, put it on ohms like that so you can see, and then we're going to take and touch the shaft and find a good ground to make sure that we have a zero reading. So now we've got a path through the Zerk going through the bearing to the shaft. Now once the motor's actually running, the lubrication acts as an insulator. Being a ball bearing or a roller bearing, either one. Ball bearing has a higher resistance than the roller bearing does. Roller bearing has a bigger path for it to pass through, so the resistance level will be lower. But the idea of using the ohm meter right now is to make sure that we've got a good ground. You can ground with one lead any place, like on the nameplate, as long as it's got a path. As you can see right there, that path is real poor trying to go through the nameplate. Now it's a little better. Right there at the Zerk, we were getting a nice path, but it can be in any place that'll give you a good positive ground. Because once again, the voltage is extremely low that we're going to try to read. We're going to be reading in millivolts in most cases. If the voltage is higher than 1 or 2 volts, that's really high. Okay? So during the time period, once again, we're going to actually be touching the frame and the shaft while it's running, and then taking a voltage measurement. The idea of this shaft brush again is to shunt the brush touching the shaft. Is a high silver graphite brush material, which has an extremely low resistivity and a high conductivity. Once it's mounted to this right here, we're able to actually read it and shunt that voltage across the ground, so we won't get any voltage readings then. From here to here, we won't see anything. If we lift up the brush when it's running, if we have a current or a voltage, either one, we'll be able to measure a small amount across there. Now, one thing I can tell you is that this is a standard ohm meter. It will be on millivolts, which is an AC millivolt reading right here. That'll be actually used for measuring. This particular meter is a oscilloscope that allows us to read up to 200 megahertz. So it's a much, much greater area that we can read. And the difference here is very little in the shop, only because we're on 60 hertz power. So we'll see the same results with both meters. But if we have a VFD out in the field, the VFD turns on, turns off, turns on, turns off by the IGBTs or the SCRs. And this scope can actually see the on and off because of the high megahertz that it's reading. So we're actually able to see it firing. And we can see how big a voltage we have in here, much better than with this meter. But for standard shop purposes, you can use the milliohm meter. You can mount it directly to a brush and use a alligator clamp onto the end of this, so it's making a nice path. You could solder one on it, keep it in a toolbox and have it so that you're making a path, but you still want to check with that brush touching to ground to make sure that you have a zero reading during the test. I have seen these come in from a power plant that were mounted on by us, and that pigtail had turned blue and melted off. So the current was pretty substantial for that to pass through. Okay, Brett, now you understand pretty much what we're going to do. Let's go ahead and run it. All right, Brett, we're going to go ahead and put on the high voltage gloves. Get ready to start this baby. We're going to start it at 55 volts. Kick it up here in just a few seconds. We're going to take it up to 125 now. Take it up to 240. Up to 41. Okay. Brett, you hold the leads up so she won't get up in the shaft area. We're gonna make a good ground. What do we got? Okay. Well, we're only reading about 45, which is pretty low. We've got an insulated bearing housing in the back end of this. But what I'm going to do is put the shaft thrust down. We're going to take another reading. As you can see, we got 1 millivolt. So that's pretty much it.